Hello everyone, welcome to my YouTube channel. Now I'm going to give in detail explanation about laws of logic. So without any further delay, let's start the explanation. Laws of logic. There are level laws of logic are there. The first one is law of double negation. Negation of negation P, we will get P. The next law is idempotent law. P or P will get P, P and P will get P. So here the uh, or is disjunctive and is conjunctive. Okay. Next, the third law is identity law. P or P or P or F. Here F is contradiction, P is tautology, and P is proposition. So if we do P or F, we will get resultant as P. If we do P and T, which means P conjunctive T, we will get P. Here or means if any one of the truth values is true, then we will get resultant as value as 3 here. And if both here the both truth value should be true, then only we will get the resultant value as true, otherwise we'll get false. Okay, moving to the next law. It is an inverse law. Here if we do P or negation P, we will get T. Here T means tautology, we will means we'll get all answers as true. If we do P and negation P, we will get a resultant answer as false, which means contradiction. As you can see here, if we do P, we will write truth values as true or false. For negation, which means opposite to the truth values. For true, uh, for P, in these P values, they are truth values. Truth and false. For negation P, we will get false and true. If we do, if we do or for this P and negation P, will get true or true, which means any of these truth tables, anyone should be true. So we'll get true. If we do or, we will get false. Both values as false. The next law is domination law, which means here obviously T is tautology, F is contradiction, P is proposition. For uh, P or T will get resultant value as T. For P and for F means contradiction, we will get resultant values as contradiction, means all will be false, some will be true, but in this tautology all the resultant values will be true only. And the next law is commutative law. It states that prepositions follow commutative property, that is, say if A equal to B, then B equal to A. So if P or Q is there, then we can write P or Q. If P and Q is there, we can simply write P and Q, vice versa. Next, I am going to discuss about absorption law. Here P and Q are prepositions. Okay. If we do P or P and Q, then we will get P as a resultant value. P and P or Q will get uh, final answer as P. So as you see in this truth table, if we do for P and Q, truth values true false, false true, false false. If we do P or Q, as you see in this truth table here, or means any one value should be true, so that we will get resultant values as true. So for true we will get value as true. For true false also, false false true means false, false means false. For here P or Q means any one value should be true. Here the both the value should be true, then only we'll get true. T as an truth value. Okay. For TT we will get true. For true false we'll get true. For false true also will true. Here false. You can see here false. So we'll get final answer as false. If we do P and P or Q, we will get same truth values as P. Okay, going to the next law, De Morgan's law. Here there is there are two negation of P or Q. We will get negation P or negation Q. Here and is changed into or. Here or is changed into and. The next law is associative law. P P or Q P or Q or R. We can simply written as P or Q or R. Next P and Q and R. We can simply written as P and Q and R. Then the next law is distributive law. We have to in simple words we can say multiply. As you see P here R and Q and R. So multiply P with this and P with R. We can see P and Q, P or Q and P or R. Here also P and we have to multiply P with Q, P with R. Will get answer as P and Q or P and R. Moving to the last law of negation for a conditional. Here for negation of P will get negation P or Q. If we keep negation before this, we'll get P and negation Q. So coming to the examples, show that negation of P conditional Q and P and negation Q are logically equivalent without using truth table. So for this, without using truth table, we have to prove this both are logically equivalent or not. So for this negation bracket P conditional Q. So apply this formula. We will get negation of negation P or Q. Negation or negation P will get answer as P. It will change or will change into and. Next, this negation will be applied. We will get negation of Q. See, we got the answer. Okay, moving to the next example. Verify that negation of negation P and Q and P or Q equal to P. So apply De Morgan's law to this. For this negation of negation P will get P. Here and is changed into or. Here for this negation P, then P or Q. And next further step P or negation Q and P or negation Q. So it is in distributive law. We have to apply distributive law in reverse. So P once see here multiply P or negation P will get P or negation Q. Next P or Q will get P or Q. Distributive law in simple words you can say multiply. So we have to apply distributive law in reverse. So as you okay, according to the inverse we will get Q and negation Q will get F, which means contradiction. Here C means contradiction. So according the next step according to the identity law P or F, we will get resultant as P. Hence proved. These both are, if we solve this, we'll get P as a resultant answer. Okay. The next example. Show that negation of P or negation P and Q is logically equivalent to negation P and negation Q. Okay. So apply De Morgan's law. Negation P for this we have to apply De Morgan's law. So negation P and for this we have to apply De Morgan's law. Okay, for negation P and for here or is changed into and then negation of negation P and Q. Then in for next step negation P and negation of negation P. According to the negation law, we will get P. Here negation Q same as this. Here for the in this step apply distributive law. negation P and negation P, then negation P and negation Q. Here, according to the inverse law, negation of P and P, we will get resultant as F, which means contradiction. You can write then F or negation P and negation Q. Ac According to the last step, according to the identity law, P or F, we will get resultant answer as P. So as you see, by applying identity law to the last step, we will get resultant answer as negation P and negation Q. So these both are logically equivalent. By by using this laws of logic, our problem becomes very simple without using truth table. So it is very easy to use laws of logic. Thank you.